Hey, what's up guys? In this series of videos we're talking all about the Internet of Things, which is kind of a buzzword lately, but really Wi-Fi modules have been around for a long time. In fact, you might remember a video I did a while back on the NRF24L01 Plus, which is a really cheap wireless transceiver. And my plan was to have these little transceivers with sensors connected all around the house here that communicated back to a single base station with a Wi-Fi module that was going to actually pump the information up to the web. But recently, with the introduction of the ESP8266, which is a little Wi-Fi module that you can buy for under $3. So now it no longer makes sense to have all these separate sensor nodes in the house that all communicate back. Now each sensor node can actually communicate directly to the web. So again, that's the ESP8266, and you can buy these for under $3. I just bought 5 of them for $15 off eBay. So before we get any further, let me show you a project I just completed with one of these to kind of get you pumped up for this series of videos. Alright, so here is my super simple demo project where we have a board mounted to the ceiling of my garage with an ultrasonic rangefinder, an Arduino, and an ESP8266. Okay, so the whole idea here is that I'm monitoring whether or not my garage door is open or closed. And if it ever is opened and the system is armed, I want to receive a text message. And I want to be anywhere in the world, and I want the interface to be accessible from anywhere in the world. So we have full, complete two-way communication from the internet and this board mounted in my garage. So here's my super simple little web interface. This is all done in PHP script using a SQL database, and we will talk about this in insane detail later on. So I'll make a separate video for creating this interface and how the PHP code works, and we'll of course get into the Arduino code running on the board. But in this video we're just talking about kind of getting started with the module, hooking it up and configuring it and kind of getting it talking to the internet. And by the way, we're not just talking about communication between this board and a web interface like this. We're also talking about getting back information from the web, like, you know, the weather, stock prices, the sports, anything. It doesn't matter. Any public data out there, we're going to be able to access from this module and get it into your project. So anyway, let me give you a quick demo of what we've got going on here. So here's the web interface. The board out in the garage is Unit 2. It's currently connected. And this is a little buggy. It's not perfect quite yet. But we can, you know, this is input we're getting from the board. It's just a random count, and it's continuously counting up from the board. This analog value here is coming from the board, and that is the measured distance off of that ultrasonic rangefinder. So it's measuring 10 feet, and that's a total distance, so down and then back up, because it does ping and then echo back. So it's actually a measured distance of 5 feet. The trigger value here is for 5 feet or 2.5 feet, and that's the distance that my garage door, when opened, is measured from the ultrasonic rangefinder. It's actually more like 4-ish, but it's a less than check. So if this is ever less than that, send me a text message. So let's go ahead and arm this. Okay, so right now it is armed, and if the garage door is opened, we will get a text message. There's a few other things on here too. We have disabled, enabled, and that changes the colors of the LED, and the video I've got playing right now up there is not real time with this. It's kind of, I filmed that before I filmed this little web interface thing. So we also have a DS18B20 on the board, which is the one-wire temperature sensor, and that is feeding this real-time temperature back to this interface. We have a brightness control here, so we can change the brightness of the LED, and that's just for demo purposes, to kind of just test everything out. So let's check this out and see if we got a text message back, and sure enough, yes, we do. So it does work, and that's just a simple demo of what you can do with this module. So now let's get into actually wiring it up, setting it up, and getting started with this whole thing. So let's keep Okay, to get started using the ESP8266, we first need to get it on a breadboard so that we can talk directly to it from a computer using a hyperterminal program or a serial monitor window in the Arduino IDE. So what we've got set up here is a USB to serial converter, some level shifting, the module itself, and since it runs off of 3.3 volts, I've got an external 5 to 3.3 volt converter over here. What's pretty cool about this part is that it has an SoC on it, meaning it's got a system on chip, which is the Wi-Fi controller and a really heavy-duty microcontroller. So if you're savvy enough, you could actually download your own application program right into the module and have that be the entire system, right? And it's got a few GPIO pins off of it that you could tie into whatever you want to control or get data from. So if you're savvy enough, you could actually do that. In my series of videos, I'm just talking about having an external Arduino talk to the module using standard, well, not standard, but the AT commands. And this has a command set that you talk to it through. And by the way, you talk to this module using a standard UART interface. So hardware serial, software serial, and you can configure the baud rate, and we'll get into that in a little bit. But as far as setting this up, it's pretty straightforward. It's just a few pins, TX, RX, ground, and 3.3 volts. But again, we do need to first set it up so that we can talk to it through the computer here, and that'll allow us to update the firmware, configure it, and test it all out. And then from there, we'll move on to controlling it via an Arduino. So I actually have a little cheat sheet over here on how I have this thing wired up, and hopefully you can see that, but this is the top view of the module. And you might want to look online before trusting my video here, because this is a new module and things are changing every day with it. So there may be a new module that's come out and maybe they change the pins around, or who knows. So make sure you check online before you hook anything up and apply power. So basically what we've got here though is it's 8 pins, and I'm connected to the breadboard here through a little adapter board I made so that it makes this breadboard friendly, and it basically just spreads the pins apart. And I'll have a link in the description where you can actually buy your own boards. If you don't want to do that, there's other ways of doing it. You can hook this into a proto board and then, you know, make little headers stand out, and you can plug it into the breadboard. So there's little workarounds. Okay, so there's 8 pins, and basically what you do is you connect the top left to ground. The bottom left is the TX pin out of the ESP8266, which you can connect directly to the USB to serial converter's RX. And since this is 5 volt, a 5 volt interface, it will recognize the 3.3 coming out of this as a logic high. The next pin over next to the TX pin on the bottom is connected directly to 3.3. The next one over, again, to 3.3. The bottom right is your source pin, and you connect that to 3.3 volts. Top left, I think I said already, is ground. The next one over is GPIO2, which I connected directly to 3.3 volts. And then the next one over is GPIO0, which is used to update the firmware. And during normal use, you connect this just to 3.3 volts. While you're programming or uploading new firmware, you tie that to ground. And we'll talk about that in a second as well. And then on the top right is the RX pin. So that's the data receive pin into the ESP8266. And for that pin, we will need to level shift it if we're connecting from a 5 volt communication interface. So what I've got here are 2 CD4050s, which are just logic buffers, and I have them tied to 3.3 volts to their source pin. And then through one of the buffers, I'm connecting the TX pin, and then it just buffers it to 3.3 volts, and then that goes over to the RX pin. That's one way of doing it, and I originally had this board hooked up to a little 3.3 volt, actually I'll bring it down here, a little 3.3 volt LCD screen, so I needed a lot more pins, and for that application it made more sense to use the CD4050. Plus, if you're going to actually communicate at a higher baud rate, like maybe 115.2 kilobits per second, then it might make sense to use the 4050 since it's fast. If you're not really too concerned about speed, and if you're just going to communicate at 9600 bits per second like I am, then you could just use a simple transistor level shifter on that RX pin to the ESP8266. So here we have just a really simple level shifter using a transistor and two 1K ohm resistors. These are both 1K. Actually, no, they're not 1K. They're 10K. Two 10K ohm resistors. Okay. So you have your TX pin from your converter or from the Arduino connected to the emitter of a 2N3904 NPN transistor, the base connected to a 1K ohm resistor tied up to 3.3, and then the collector tied to 3.3 as well through a 10K ohm resistor, and then that heads over to the RX pin of the ESP8266. And this is the same setup I have out in the garage, and it runs perfectly fine at 9600 bits per second. So that is the hardware setup. Really nothing to it. And by the way, there's a ton of resources online too for all this. So definitely check that out before applying power. So now let's talk about uploading new firmware to the part. Okay, so I've connected the USB to serial converter up. We do have power on. The red LED on the Wi-Fi module should be solid red, and we should be good to go. So let's first just check to make sure that the connections are all good to go. So I'm going to launch the Arduino IDE here, go in, select the right COM port, we're good. Launch the serial monitor window. Make sure you've got both new line feed and carriage return selected down here. This default baud rate is 9600 bits per second. I did get a few modules that out of the box were at 115.2, so you may need to go down there and select that in case 9600 does not work. So let's just go ahead and ping it real quick and do an AT. So the letter A, letter T, enter, and you should get OK back. So we're good to go on this. So let's go ahead and unplug. I'm going to unplug the USB to serial converter. So I've removed power. I'm going to switch GPIO 0 now to ground. I'm just going to connect it directly to ground. Okay, that's connected to ground. I'm going to power it back up. Okay, so now we're going to update the firmware. So I'm going to have a link to this little wiki here in the description. This is from Electrodragon, and I think they've got the best documentation on this module out of everybody so far, at least. And it's just a good spot to go to for a quick reference, or if you need to get somewhere else, because they do have links to other resources on here. So let's go down to firmware here and go to, where am I going here? Okay, I just want to find where the firmware is. Firmware. Okay, and I want to go find most updated firmware on this Google link. Okay, and this should take me to a Google Drive. Here we go, official firmware. I just want to show you where to get the firmware that I'm actually running with. All right, and this is what I'm running with here, is the ESP8266 Flasher V00180902_03.zip. Okay, that's what I'm using, so download that. And by the time you watch this video, there'll probably be like 10 more versions of this firmware, but that's what I'm running with right now, and it seems to be very stable and reliable. Okay, so once you unzip that, you can open it up. I'm running 64-bit Windows here, so I'm going to launch this Flasher utility, and it opens up this little window here. You select the COM port and hit this, which I'm assuming means go or flash. Okay, and you can see the progress bar is doing something. Okay, so now the firmware has been updated. Let's unplug the USB to serial converter. So we remove power, and I'm going to move that wire connected from GPIO 0 from ground to 3.3 volts. Power it back up. We'll launch the Arduino IDE and give it a quick test. AT, and we're good. All right, so let's now go through and test it out and see. Well, actually, let's test one more thing. AT plus GMR will get the what firmware is actually on the board. So that was 18.000.902, which 902, but it's, I guess it's underscore. I guess they're not showing you the 03 there in that response. So now let's dig into this a little further, and I'll show you what this module can do. Okay, so now we're ready for the fun stuff. We've got the firmware updated. We're all hooked up. We're communicating. Now we can actually talk to the internet. And sorry that was kind of rushed through this video. I'm kind of trying to just get it all out there now so that we can actually get into some of the cooler stuff, but I'm just kind of blasting through everything. So let's just go through the commands. So now we're connected to the module, so we can just issue an AT and we get the OK back. So that's good. Let's do a reset. So that's AT plus RST. And that'll reset the module. You'll get an OK, and then you'll get a little thing back, a little kickback, system ready. So if in your Arduino code you needed to issue this reset, you would wait for something like, you know, system ready or whatever. And it's kind of funny, from firmware version to firmware version, this message changes. And I noticed that when I changed the firmware to the latest one that I showed you. They actually made this R lowercase. So it screwed up my whole, you know, checking feature of the code. So anyway, we'll get to that later on in a future video. So, okay, AT plus GMR, let's check that firmware. Let's set the mode now, CW mode, and if you do equals question mark, it'll tell you what it'll accept. So if I were to change this CW mode, which is actual mode of the Wi-Fi module, so it could be a station, which is basically like a device on your network. It could be an access point, so you can log into it, or it could be both. I haven't really played around with the access point function yet, but that'll be coming up soon because I do want to make a web interface that you kind of log into and you can set up the SSID and password and everything, and then, you know, it's kind of just a completely standalone device. All right, so let's go ahead and do AT plus CW mode, and without the equal sign you can just do a question mark, and that will tell you what it's currently set at. So it's currently set to a 1, which is fine, which equals station. And you can look up all these commands. I'll have a link in the description. You can look them all up, and there's fully detailed explanations of all these different commands. Okay, so now let's do AT plus, let's list all the access points. So CWLAP, give it a few seconds, and there we go. So it's listing all the access points. We're going to go ahead and connect to test there. So AT plus CWJAP, joint access point, equals, quote, test, comma, quote, password. How you type in your password. Mine's password. Enter. Up. Error. What did I do wrong here? CW join. What did I do? Up. I forgot a quote. That's right. Okay. It's pretty easy to miss little easy things here. So there we go. Now it should take it. So give that a second. We should get an OK back. All right, we got the OK back. Great. All right, so now we're connected. Let's double check that we're connected to a CWJAP question mark. And yes, indeed, we are connected to test. Now we're going to do AT plus SIPMUX equals 1. So this is setting it to accept multiple connections, which is required for the TCP connection we're about to do to the internet. So you set that to 1. And this needs to be set every time on boot up or power down, power up, reset. You have to set this every time. It does not save this when power is removed. Okay. I don't think it'll let me change SIP mode, but we want to keep SIP mode 0. Nope. So let's issue a reset. After all that configuration, let's do the reset there. Wait for the kickback. There we go. AT plus SIP mode now equal to 0. We want to make sure that's 0 so that it is set for, I'm just looking for the definition of this, so not data mode. So I think if SIP mode was set to 1, I haven't played around with that yet either, but I think if it's set to 1, you can sort of do a streaming connection. So AT plus SIP, no, what do I want to change? SIP mux, that's the one. SIP mux equal to 1, okay. All right, now we're ready to start a connection with the internet. So let me stop. Okay, so I just wanted to change gears for a few seconds here. Now we're about to communicate with the internet, and we're going to try to retrieve the weather for Cleveland, Ohio. And to do this, there's a few different ways you could do this. The way I do it is I use Yahoo's query language. So I've used Wi-Fi modules in the past, and usually what you do is you access a web page and you read back the entire web page, all of its HTML in text form. So it basically just blasts it down the UART, and you're reading out this entire web page in text, waiting for certain keywords. And when those keywords hit, then you know that your data, is in between two keywords. So you have to come up with this really complicated code to basically create like a buffer, a rolling buffer, and it can get kind of messy. And the other thing too is, when you're reading a giant web page back in text, you need a fast UART, because it could take like up to 10 seconds to read it back an entire web page, using like a 9600 bits per second UART. So Yahoo query language, you can actually put in different websites in here, and you can query out different keywords, things you actually want, the data you want, and then they give you a link here, and then when you use that link, it'll give you back just the parsed data you want. So I'll probably make a separate video showing you a few different things you can pull out using this query language here. But there's plenty of examples here. You can see all the things that they give you examples for. But I'm just gonna kind of show you what I did here. So I'm selecting, item.forecast from the weather.forecast where blah, blah, blah. And this sets up the location you want to grab the weather from. I'm getting it back in JSON format, no diagnostics, no debug. And if I test this, you could see here what it kicks back here. It kicks back the results, and you can see the forecast. So date Monday, high, low, text is light rain. So it's kind of cool, and it gives you, I don't know what that is, like the 4 or 5 day forecast. And then down here it gives you the link. So I'm going to copy that now and then just throw that into, all right. So now you can see when you just use that link plain, it just gives you this. So that's much easier to work with than an entire web page. So let me show you an example. Like if I went here and I went to develop and I went, I don't know, where show page source, just for this. You see all this crap? That's what I would normally get back from any web page. I mean, it all comes back as a giant block of text. So I just wanted to show you that real quick. Now, kind of the problem with the ESP8266 is you can tell that this is a huge link down here. It's massive. So when you're sending that over to the ESP8266, I found that it can be kind of finicky. Maybe there's the buffer, the serial buffer on the chip can't quite handle that entire giant link. So then I use something called Thingspeak. Okay, so this is Thingspeak here. And this is like, this interface you can use to handle all of your data. You can plot your data. You can have this actually handle the, check this out. Let me just show you an example. So if I go over to apps, Thing HTTP, I can have it call that link for me, and it'll give me another link. So it's kind of backwards. But if I go in here and I already had this set up, paste that link in here, and then save this. Don't worry, I'm going to change the API key. And then it'll give me this link. So now I have a much shorter link that I can call from the ESP8266 to get that data back. Okay, and now if I called that link, pop that in, I get the same data back. Okay, but you know, that sounds kind of crazy, but you can use this Thingspeak to do all kinds of stuff. And I haven't even tested this out yet, but like now you can not only get public data, but it looks like you can also get things like maybe things out of your Facebook, maybe things, you know, out of your email, you know, private data, things that you need to log in for. So I haven't tested that out yet, but I'm going to. The other thing you can do here, I'm going to go here and then go into this, is you can actually plot data as well. So I was plotting some data from a temperature logger, and it's the same idea, not temperature logger, but I had the DS18B20 temperature sensor, and I was basically just pumping that up. The only problem with Thingspeak, though, is there are limits on how often you can update how often you can call this link, the API refresh rate. But if I go here to data import export, so now for this channel here, it gives me this link here. So if I do a call on this, I can change that field 1 to be something. And I'll show you an example of that in a second, but let's first get that weather down. Okay, so now we're back, and I just showed you, you know, the Yahoo query language and the Thingspeak server. So now we can actually grab the weather down. So what we do is first we need to connect to the Thingspeak server. What's cool about this, the ESP8266, is that it allows you to basically put in a domain name, not the IP address. So I can do an at.zipstart equal the channel of the device. I think you can go 0 to 3, 0, 1, 2, 3. I think it's got 4 channels that you can connect on. 4 would be all channel. I'm not sure exactly, but I always use 0, comma, quote, TCP, comma, or quote, and because we're going to use a TCP. I think you can, this module supports UDP as well. Quote, and then the api.thingspeak.com, quote, comma, 80. So we're going to connect on port 80. So we'll go ahead and do this. Now we're going to be, as soon as I do this, hit enter, we're going to be on a countdown timer because the connection can close at any time. So we're going to go ahead and do this. Okay, linked. Now the next thing we need to do is an at.zipsend on that same channel 0. And then the 110 is how many bytes I'm sending. And I just chose a big number. Okay, and we're gonna see if we can get the, and then this format is critical. So we do a get, and then that entire link, and then a space http:/1.0. All right, I'm gonna put that in, and then I'm gonna start tapping the enter button because we need to get all those new line feed carriage returns in. So, okay, so here's the data. It's sent out. You should get, when you actually write this in your code, you're not just going to send, you know, some large number. You'll actually create a string here for this entire thing. And what I usually do is have in that string two new, well, it'll be a new line feed carriage return, new line feed carriage return. So you have that twice, repeated twice. And you read that whole thing into a string, and then you do that string dot length in for this value here, so that you're doing a zip send of the exact number of bytes you're going to send. Okay, and then you get a send OK, and you will get, these errors are just because I was tapping the enter key. And then here is everything. It did send OK, and then you get the query down here with the results, and there's your forecast. So now we were able to successfully get information from the internet. Now let's do the same thing, but this time we'll use that link to send data. And I'll show you that in a second. Let's reconnect. Let's do a zip send of 110. And I'm going to set the value. Let's set the value for 100. I just changed that. So right here, the get and then that whole link they gave me. And then when I go over here, you can see and field 1 equals to 100. Let's let that go, and then tap the enter button, and there it goes. All right, so it looked like it took it. Let's go in now to the interface, and I'm going to go to the public view, and there it is. So that's pretty cool. So this is the little graph that they give you, and you can actually take this, I think, and it'll give you the HTML, yeah, the iframe. So you can embed this in your website or some web page you created with a bunch of these charts, and do whatever you want. You can also get this data back from it, so you can store your data there, and you can also store and view your data on other servers, other data servers as well. Like SparkFun has something going on, and Adafruit, I think, is just about to launch their data server. So anyway, just a few different places you can go and do the same sort of thing. So that is kind of what I wanted to accomplish with this tutorial. Up next will be the full PHP script, the whole PHP code side, the Arduino code side, the SQL database side. So there's a lot coming in this series. So hopefully that'll kind of kickstart you and get you running with this. So I know it's a long video, but thanks for watching.